This topic is about being able to recognize what a stretch looks like on a curve graphically and algebraically. We need to be able to stretch different types of graphs and give coordinates of points after a transformation. So let's look at the two different stretches you can have. So the first type is a times f of x. So let's compare the graph of f of x equal to x squared and g of x, which is equal to 3x. So think about what happens when you transform y equals x squared to y equals 3x squared by plotting both graphs in the same axis. So if I have y is equal to f of x, which is equal to x squared, then minus 3 all squared will be 9, minus 2 all squared will be 4, minus 1 all squared will be 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now, if we're doing 3x squared, it's the same thing as 3 times f of x, okay? So what we've done is we're looking at the case where it's a times f of x, where a is outside the bracket. Okay, now 0 squared is 0 times by 3 is just 0. 1 squared is 1 times by 3 is just 3. 2 squared is 4. 4 times 3 is 12. And 3 squared is 9. 9 times 3 is 27. Because we're squaring first and then timesing by 3, you get the same on the other side. So it's 3, 12, and 27. And when we plot these, so if I plot y equals x squared, you know obviously it'll look something, I don't want to draw it to scale, but you know it'll look something like this. Y is equal to x squared. Now, if you look at y is equal to 3 times f of x, which is 3x squared, you'll see the y value multiplies by 3, which means if I draw it out, it'll look like this. So it'll be much steep. Y is equal to 3x squared, which is 3 times f of x. And that one is just f of x. And what you can see is it's a vertical stretch by a scale factor of 3. To be stretched vertically by a scale factor of 3 parallel to the y-axis. So what you realize in general is if you have the case a times f of x, then it is a vertical stretch by scale factor a parallel to the y-axis. So that is what happens when you do a times f of x. Now, if you do f times fx, a of x, where a of x is in the bracket, a is in the bracket, let's compare x cubed with 2 of all x cubed. So you know this is f of 2x, because you replaced x with 2x. So what happens in this case? So x cubed, if you do x cubed, you get 0. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. When you substitute the negative numbers, you're going to get a negative answer. So you get negative 1, negative 8, and negative 27. If you do 2x and then cube it, it means you have to times the x coordinate by 2 and then cube it. So 0 times 2 is 0, cube it gives you 0. 1 times 2 is 2, 2 cubed is 8. Minus 1 times 2 is minus 8, minus 2. Minus 1 times 2 is minus 2, cube it gives you minus 8. Similarly, 2 times 2 is 4, 4 cubed is 64. If this one is 64, that one will be negative 64. 3 times 2 is 6, 6 cubed is 216. So if this is 216, this one will be negative 216. So if I were to sketch this out, this is x, this is y, then this is normally x cubed. Y is equal to x cubed, which is equal to f of x. And if I look at these numbers, 1, it goes to 8. So if you look at it, it grows more quickly. So I should use a different color. if this one is y is equal to 2x all cubed, which is f of 2x, is growing more quickly. So it's actually a horizontal stretch. So it's a horizontal stretch, but it's been, although we say it's a stretch, it's actually been squashed. But if we say it's a horizontal stretch, because it's squashed instead, it's by scale factor the opposite. So scale factor instead of 2, what's the reciprocal of 2? It's a half. So it's a horizontal stretch by a half, means it's been squashed. So it's getting everywhere 2 times faster. Yeah. Parallel to the x-axis. So if we were to say what is happening in general, f of a of x, so when a is in the bracket, it's a horizontal stretch by scale factor, again, because it's the x that's being affected, like before, the opposite thing happens. So it's by scale factor 1 over a, parallel to the x-axis. Okay, so in an exam, you're obviously asked to describe these transformations. So how can you describe them correctly? So what is the correct terminology you can use? Okay, stretch the curve by scale factor 5 on the x-axis. That is wrong. Okay, because why would you stretch it on the x-axis? It's affecting the whole grid here. Next one is stretch the curve by scale factor a quarter parallel to the x-axis. That sounds good because it's parallel to the x-axis, not just on the x-axis. And we've mentioned the scale factor and we've mentioned the stretch. Stretch the curve horizontally by scale factor 4. Parallel to the x-axis and horizontally, you can say either. Obviously, in my descriptions here, I've said both. But you can say one or the other and you'll be fine. So that is correct. Next one, stretch the curve by scale factor 3 across the y-axis. That sounds wrong to me. You can't have it across just the y-axis. Stretch the curve by scale factor 1 over 10 in the y-axis. Again, wrong. So only thing that seems to work is parallel, yeah? Parallel to the x-axis. We'll cross these out as well. Next one, stretch this curve by scale factor half in the y direction. That is correct because in the y direction means the whole parallel to the y-axis. Sketch the curve by scale factor 2 across the x-axis. Again, that sounds wrong because we're just talking about the x-axis. Stretch the curve by scale factor 7 along the y-axis. Does not make sense again. And stretch the curve in the positive y direction by scale factor 1 over 5. Because it's positive y direction, that does not make sense. You can't talk of, because positive y direction is more used for translation. That's not correct. So note, avoid using enlarge, because a stretch can either be enlargement or obviously a reduction, but we don't want to use those words. So instead, we want to use the word stretch with a scale factor. So avoid using enlarge or squash. Okay, you might not get the mark. And also, the most ideal one to use is 2. So 2 is ideal response in an exam. Okay, so let's go through the examples. So it says, describe 2 different transformations, each of which would map the graph of y equals 1 over x onto the graph of y equals a third x. So if f of x is equal to 1 over x, then f of 3x will be equal to 1 over 3x, which is what we want. So this is a stretch because it's 3x, it's inside the bracket. So by stretch by scale factor, the opposite thing happens inside the bracket. So a third parallel to the x-axis. In a similar way, if you do 1 over 3 times 1 over x, it's the same thing as a third times f of x, which is 1 over 3x. So that is a stretch by scale factor a third parallel to the y-axis. So these are the two transformations that gives you y is equal to a third x. 1 over 3x, sorry. Okay, B. Describe two different transformations, each of which would map the graph of y equals x squared onto the graph of y equals 4x squared. So if f of x is equal to x squared, then 4 times f of x will be equal to 4x squared, which means it's a stretch by, because 4 is outside the bracket, by scale factor 4 parallel to the y-axis. But 4x squared is also the same thing as 2x all squared, which is the same thing as f of 2x. So it's this, because it's inside the bracket, it's the x that's affected, so stretch by scale factor, the opposite of 2 is a half, by scale factor a half, parallel to the x-axis. So if it's the x that's affected, you do the opposite for the scale factor, reciprocal for the scale factor. If it's the y, it's the same. Okay, next one. The diagram shows the curve with y is equal to f of 2x, so this is very important. It's not f of x, it's f of 2x, which crosses the coordinate axis at the points minus 2, 0 and 0, 1. Showing the coordinates of any points of intersection with the coordinate axis, sketch on separate diagrams the curves y is equal to 3 times f of 2x. So y is equal to 3 times f of 2x, which is the original one, is a stretch by scale factor, because it's outside the brackets, the y affected, so scale factor would be 3, and parallel to the y-axis, which means all the y coordinates multiplied by 2, so minus 2, 0, mapped by 3 f of 2x, only the y is multiplied by 3, so it becomes minus 2, 0 times 3 is just 0, yeah? So only the y multiplies by 3. And in a similar way, if I were to do the other one, which is 0, 1, 0, 1 under the map of 3 times f of 2x, only the y will multiply by 3, so 0, 3. Only the y value will multiply by 3. Which means if I were to sketch it out, I'm going to have to sketch it here. X or y, it'll still go through minus 2, 0. So minus 2, 0. But now it will go through 0, 3 on the y-axis. So it'll look very similar, just a stretch. Okay, this is y is equal to 3 times f of 2x. Okay, if I'm doing y is equal to f of x, okay, so f of x is what I'm trying to draw. To go to f of 2x, it's a stretch. So if I'm going from f of x to f of 2x, it's stretch by scale factor a half, f of x to f of 2x, because the x has multiplied by 2, parallel to the x-axis, parallel to x-axis. So if I'm going backwards, it means I need to do a stretch by scale factor 2 now, yeah? Because if it's a stretch by scale factor half going forward, then going backward would be stretch by scale factor 2, parallel to the x-axis. Which means if I start off with the points from f of 2x, so if I start off on minus 2, 0, and that means if under this mapping, I'm going to have to stretch by scale factor 2 parallel to the x-axis, it means my x coordinate has to multiply by 2. So I get minus 4, 0 for that one, and the other coordinate 0, 1, only the x coordinate multiplies by 2, which means I get 0, 1 still. So the x coordinate multiplies by 2, which means that I'm sketching it x, y. So now it goes from minus 4, 0. This is minus 4, 0. The 0, 1 is still the same. So we look something like this, and this is f of x. Okay, next question. So sketch the following graphs given the coordinates of the maximum point in each case. So f of 2x is so let's go to here. A is equal to f of 2x. It's a stretch by scale factor a half, because it's the x that's affected. So you have to do the reciprocal of 2, and parallel to the x-axis, which means 0, 1 stays as 0, 1. Okay, which means 0, 1 under f of 2x stays as 0, 1, which means if we sketch it, it'll just get there faster, so it's just going to be a bit more narrower, but still the point 0, 1 stays as 0, 1. B is 3 times f of x, is a stretch by scale factor 3, because it's outside the bracket, parallel to the y-axis, which means 0, 1 under 3 times f of x will become 0, 3, because all the y coordinates will multiply by 3, which means if I were to sketch this x, y, now the maximum point would be at 0, 3. Last one is C, which is f of a half x is a stretch by scale factor, because it's inside the bracket, reciprocal of a half is 2, and it's because inside the bracket is parallel to the x-axis, which means 0, 1 under f of half x. The x coordinate multiplies by 2, but 0 times 2 is just 0, so that point does not change. So when I'm drawing this, xy is still going through 0, 1. It'll just possibly get there, but it's not, so that is bad drawing. Let's try again. Okay, that's it. Okay, for f of x is equal to x minus 1 times x minus 3 times x plus 2, sketch the following graph showing the coordinates of the points where the graph cuts the coordinate axis. For each of the parts 2 to 5, write down the new equation. You do not have to fully simplify. Okay, so 1 is just f of x, which is equal to x minus 1 times x minus 3 times x plus 2. So if we're drawing this out, x and y, it's a cubic graph, positive cubic graph going through negative 2, positive 1, and positive 3. And the constant, the y-intercept is going to be minus 1 times minus 3 times 2, which is a positive 6. Positive 6. It's a positive cubic graph, so starts off of quadrant 3, ends up at quadrant 1. So this is y is equal to f of x. Okay, we don't have to write the new equation for this one, so you can just leave that part. Second one is y is equal to 4 times f of x, which is 4 times x minus 1 times x minus 3 times x plus 2. So this is a stretch by scale factor 4 parallel to the y-axis, which means all the x-intercepts will still be the same. The only difference is the y-intercept will multiply by 4. So 6 times 4 is 24. It doesn't matter that it's not drawn to scale or hasn't really become bigger. As long as you label it right, it's fine. 3. So it's going to similar shape, scales change. Okay, number 3, which is f of 2x is equal to, everywhere we see an x in the original function, we replace with 2x, 2x minus 3, and 2x plus 2. So it's a stretch. Because it's inside the bracket, the reciprocal of 2 is a half by scale factor a half. And because it's inside the bracket, it's parallel to the x-axis. Which means now, if I think about the roots, so this is y, x, x. Okay, the roots will now divide by 2. So instead of going through 1, it's going to go through a half. Instead of going through 3, it'll go through 3 over 2. Minus 2 divided by 2 is minus 1, so it'll go through minus 1. The y-intercept will remain unchanged, so it still go through 6. So it'll look like so. 4. F of a half x. Everywhere we have an x in the original, we replace with a half. So we've got half x minus 1 times half x minus 3 times half x plus 2. Okay, so this is a stretch because it's inside the bracket. The reciprocal of a half is 2. So by scale factor 2, parallel to the x-axis. So if we're sketching this out, y and x, so now it will go through, instead of going through 1, it will go through 2. So it'll go through 3, it will go through 6. Instead, because we're multiplying everything by 2, instead of going through minus 2, it'll go through minus 4. The y-intercept will remain unchanged at 6. Like that. Last one, 5. A third times f of x is equal to a third times x minus 1 times x minus 3 times x plus 2. So it's a stretch by scale factor a third because it's outside the bracket, so it stays the same. But it's parallel because it's outside the bracket, it's parallel to the y-axis. So again, the roots stay the same, which is minus 2, 1, and 3. But the y-intercept, which is 6 times by a third, 6 times by a third is 2. So the y-intercept will now be 2. If you join it up, you get something like this. Next question. The point P2 minus 3 lies on the curve with equation y is equal to f of x. State the coordinates that point P is transformed to on the curve with equation y equals f of 2x. F of 2x is a stretch because it's inside the bracket, it's reciprocal of 2, so stretch by scale factor a half. And because inside the bracket, it's parallel to the x-axis. Parallel to the x-axis. Which means the x-coordinates multiply by a half. So that means 2 minus 3 under f of 2x, the x-coordinates multiply by a half. So 2 times a half is 1, 1 minus 3. So the answer is 1 minus 3. B, we've got state the coordinate that point P is transformed to on the curve with equation y is equal to 4 times f of x. 4 times f of x, the 4 is outside the bracket, so you keep the 4. So stretch by scale factor 4, and it's parallel to the y-axis because it's outside the bracket. So that means the point 2 minus 3 under the transformation f of 4x, the y-coordinate multiplies by 4, which is minus 3 times 4, which is minus 12. So 2 minus 12 is the answer. The next question, the point Q minus 2, 8 lies on the curve with equation y is equal to f of x. State the coordinates that point Q is transformed to on the curve with equation y is equal to f of half x. So f of half x, because half x is inside the bracket, it's a stretch by scale factor. The reciprocal of a half is 2, and parallel to the x-axis because it's inside the bracket, sorry. So parallel to the x-axis. Okay, so that means when we take the point minus 2, 8, under the transformation of f of half x, the y coordinate stays the same, but it's the x coordinate that we multiply by 2. Minus 2 times 2 is minus 4. So the answer is minus 4, 8. Okay, next question, which is the last question. Sketch the graph of y is equal to x minus 2 times x minus 3 squared. So A is a cubic with a double root at 3. So if I were to sketch this, x and y, so there's single root at 2 and there's a double root at 3. And minus 3 times minus 3 times minus 2 is 9 times minus 2, which is minus 18. So that means it goes through minus 18 in the y-axis. So it's a single root at 2. So it's going to go through, cross over at 2. It's a double root at 3, so it's going to bounce off 3. And it was a positive cubic graph, so it does start off from quadrant 3 and goes to 1. So this is y is equal to x minus 2 times x minus 3 squared. Okay, part B. The graph of y is equal to ax minus 2 times ax minus 3 squared passes through the point 1, 0. So that means this is y is equal to f of ax is equal to ax minus 2 times ax minus 3 squared, which is a stretch inside the bracket. So stretch by scale factor. Inside the bracket means the opposite, so reciprocal of 1 over a parallel to the x-axis. Which means if I sketch it out now, okay, the two roots will be 2 over a and 3 over a. And the y-intercept will still be minus 18. Okay, now the other thing that it says is it passes through the point 1, 0. So we will either have 2 over a is equal to, because it's a root, is equal to 1, or we have 3 over a is equal to 1. Okay, now if 2 over a is equal to 1, then a must be equal to 2, or 3 over a is equal to 1 means a is equal to 3 over 1, which is 3. So these are two possible values of a.